jetzt beginnen. Also ich starte die Aufzeichnung, die Übertragung und mache dich zum Moderator. Bis dann.
Die Sprachübertragung beginnt jetzt. Alle Teilnehmer befinden sich im Zuhörermodus.
Hello and cordially welcome to the webinar to the CODESYS OPC Ua Server. My name is Roland Wagner. I'm the head of the product marketing of 3S Smart Software Solutions, and I'm happy to welcome you to this webinar. You see that the chat is open during the presentation, so in case you want to pose your questions immediately, you can do so. In any case, you can as well ask me or the colleagues after the webinar, and we will try to answer all the questions immediately. Otherwise, we will send you an email as we have your email address after the registration. Please note that you can immediately as well download the presentation to the webinar in the chat window. So let's start. First step, I want to give you a short introduction to OPC and Opc Ua, even if I'm of the opinion most of you should know about OPC and Opc Ua, but nevertheless, I think it's a good idea to bring everybody to the same level. Then I want to show you how the CODESYS OPC Ua Server is integrated, how to use it, and at the end I will give you some outlook information and a short conclusion for it. So let's start. In the past, it was always a big question in case you were working with PLCs and with inputs and outputs, drives or anything else at the field level. How can I visualize my PLC in my visualization tool? In the past, the suppliers of visualization systems, they always had to write specific drivers to PLC families, and of course this was a very boring job, because every time there was a new PLC there was a new driver for the visualization necessary. So therefore there was a standardization introduced, OPC, and originally it was based on OLE, which was a Windows standard for object linking and embedded. Today it's not more fashion to talk about OLE, because in fact this is a standard which is no more continued by Windows. Nevertheless, this OPC standard is really based on Windows services, as we see here in this block diagram. We have the visualization up here, and we have the controller down there. The controller is communicating with a specific driver, which is then handling data to a so-called Opc Server. And this uses Windows services COM and DCOM in order to transmit this data to the Opc Client, which is then implemented in the visualization. So with this method, it's possible to have a standardized communication between the controller and the visualization system. Now CODESYS supports OPC already for a very, very long time. So even for version 2.3 and of course for version 3, OPC is supported. There's different profiles, for example data access, which is supported for version 2, and data access and alarms and events, which is supported by the newer Opc server. By the way, this new Opc server is able to handle both CODESYS version 2 and CODESYS version 3 controllers, and it's available as well for Windows CE, as there are these communication services as well available. Let's take a short look at the graphic here. We have the PLC, which is handling the application, and you know that there is a communication server, the so-called gateway server, which is always in between CODESYS and the PLC, and the OPC server is now working on top of that gateway server. So it uses the services inside that gateway server and provides them this standard communication to OPC clients via COM and DCOM. Why should we move from OPC to Opc Ua? Ua for Unified Architecture. Of course, one major point is to get rid of that Windows restriction or Windows limitations. So we need a platform-independent standard which can be as well be executed on other operating systems, on other devices which are non-Windows. And we will see that later that this is really working perfectly. Furthermore, it is the idea to make use of modern and portable technologies, Ethernet protocols, web protocols, which are very widespread right now, so there should be the base for such a communication. The next idea is to have a communication stack for that protocol which is portable and which can be ported to almost any system. This protocol stack is available in ANSI C. It's provided by the OPC Foundation and it's free of charge for all members of the OPC Foundation. So what we did is as well take that ANSI C stack and implement it into a special runtime component and provide it to you as device manufacturers or as end users in case you're working with soft PC. But this is something we're talking later on. Another requirement is that in opposite to OPC there should be a very lean data exchange between server and client. There should be a simplified server configuration, and as one major benefit, there should be a functional access to the controller. For example, out of the visualization, there should be some methods be called on the PLC, which is of course a very huge and mighty new feature. Let's take a look at the block diagram. We have the controller down here, and either with a dedicated Opc Ua server or with an integrated Opc Ua server, including that communication stack, we can now build up communication to an Opc Ua client by means of Ethernet TCP or by the means of Ethernet TCP with a binary protocol or with a HTTP XML-based protocol. So the visualization with the Opc Ua client can directly be connected to the controller or to the Opc Ua server on the field level. Some features of OPC Unified Architecture. As already mentioned, there are two different data exchange possibilities. The first one very slim in a binary format for very slim and effective communication. And there's another one based on web services with a SOAP, which means XML via hypertext transport protocol transferred between client and server. One major thing which was already part of the specification from the beginning of Opc Ua is an integrated secure communication. So this means that the server communicates via the stack to special services which push the data then through a secure channel, to the application session, and this is then decoded by the client and the other way around. The whole thing is a service-oriented architecture. We have the services here such as query, read, write, subscribe. There's an information model with different profiles, similar to OPC. One more specific feature is the object model. So objects have up-to-date and monitor data, events, methods. Complex data can be used in variables, methods, and events. Objects, variables, and methods are represented as nodes in the address space. We will all see that in the live demonstration in a few minutes. There's typed references between the nodes. There's a meta information per object. There is a address space with types and instances, and object types which are represented as classes described in the same way as the objects, which are then instances. So we have a real object model which fits perfectly to an object-oriented programming, which is a as you know, possible in CODESYS. Now, how is an OPC server integrated into CODESYS? The first step, you need to know that the CODESYS OPC server is an option for the CODESYS control runtime system. So in terms of commercial issues, it's a buyout option which you can, as a device manufacturer, purchase together with the runtime toolkit which you need in order to implement the CODESYS control runtime system, the soft PLC, onto your controller. And with that option, you turn your device into an Opc Ua server, exclusively for version 3 controllers, and you need to have the access to the runtime system, so it's only available first step for the device manufacturer. As there are the sys interfaces used of the CODESYS control runtime system, the Opc Ua server basically runs on all ported runtime system platforms. There's nothing special needed except an adequate amount of resources. So the resource consumption of that Opc Ua server on the runtime system is of course not that low. So this means for the Opc Ua server you need almost the same resources as for the complete runtime system. Even if you may scale or configure the Opc Ua server, so there might be some less performance and some less memory of the controller needed. But nevertheless, we'll talk about that later on. It's probably not that suitable for very small controllers. The CODESYS Opc Ua server supports the PLC open information model. So the data types of the PLC open are supported and used. What is not yet supported, but which is in the making at the moment, in the development, is the secure communication via X509 certificates. So this is something that is at the moment implemented, and we plan to release that secure communication with CODESYS version 3.5 Service Pack 10, which will be released in December 2016, so this year. Some benefits of the integrated Opc Ua server. One big benefit is that there is a very easy implementation. The only thing you need is the option for the CODESYS control runtime system, and then the Opc Ua server is automatically included with your runtime adaptation, no matter which platform you adapt. With that, your Opc Ua server, you have direct access to the verbal interface of the runtime system. So it's similar than the PLC handler. You can directly access the symbolic data on the runtime system. And there's the Opc Ua stack, which is used in the server, but it's the same stack that will probably be used as well in the client. So we have a very good communication, and there will be probably no problems as it was in the past with standard OPC, because perhaps you know there were sometimes not very strict implementations of that UPC standard, and therefore there might be some communication problems. With that standard Opc Ua stack, which is running in the server and in the client, these problems are gone. One major benefit is that the CODESYS Opc Ua server is implemented in all soft PLC, which you can immediately download from the CODESYS store. So in case you want to make your own tests, don't hesitate to go to the CODESYS store, register in case you did not do it so far, and download the soft PLC. For example, CODESYS Control Win, which is, by the way, as well already installed with the standard CODESYS development system. And then you can immediately build up Opc Ua communication. And I will show that in a minute. Just one more slide, which I already mentioned. What about small controllers? As mentioned, Opc Ua server needs a certain amount of resources on the controller, so this may be too much for small controllers. Nevertheless, there's a workaround available. You can swap the Opc Ua server to a more powerful device in the network. So in case you have a network with different PLCs and there's, for example, a more powerful one available, then you take this one, or you install a standalone device with the Opc Ua server, which is at the moment possible by means of a soft PLC. In the future, there will be a standalone Opc Ua server as well available. And then, in case you have such a separated server, you can collect the data by means of the CODESYS data server from the small controller to the more powerful controller, and then distribute that data in the network to the clients who want to use it. Okay, but now finally we want to take a look how we can use the CODESYS Opc Ua server in a live demonstration. I switch to a CODESYS project which is already running, and as you see here, I have realized that by means of a Raspberry Pi. So you know that standard platform which is very cheap and very easy to use, and you know perhaps that there is a soft PC available for that Raspberry Pi, and exactly this is the one I'm using. And I'm already connected to that Raspberry Pi, which is here on my desk next to me. I have a wireless LAN access to it. There's a DHCP server running on it, so I can immediately access to it via my wireless LAN. And I have downloaded my application and I'm executing it. Now, but so far without Opc Ua. How can we now add Opc Ua? In order to do so, go to my device tree, to my application, and add here an object, which is so far not implemented. It's the symbol configuration. And as soon as I do so, I get a small configuration window, and the most powerful thing I need to switch on here is support Opc Ua features. There's some more options, but we want to concentrate right now on Opc Ua. I add that, and you see that this symbol configuration is then immediately opened and available here in my device tree. So, by the way, in case I want to change something, there is the settings menu up here, which contains the same setting possibilities as we had in the window before. You see here that there is a message with a black exclamation mark on a yellow sign, which tells me before I can configure the data that should be transported by Opc Ua, I have to execute a build. So this means the project should be compiled in order to make the variables available for the symbol configuration. Now I've done so, so this message here disappears, and now then I can select data from the symbol configuration which I want to distribute, for example this simple counter here, which is in the global variable list, and then take some more variables, for example an array here, another counter here. I could even take an instance of a function block here and here, and you see that this button here on the right shows me that I can go more in detail into the instance of that function block, and in case I want to limit the data which is transported by Opc Ua to just single or certain variables. In this case I take all of them. Now this is all. What I have to do right now is to download that simple configuration to my controller, so I log in once again. In this case I choose the option log in with online change. So this changed project, the only change was the simple configuration, is now downloaded to the controller and executed there. So you see that I've already prepared a watch window, so we see some variables already moving in here. We saw that before. What has changed? Nothing visible so far. We have installed an Opc Ua, so now we need an Opc Ua client in order to see whether this data transfer really worked. I've prepared a standard client for you is the so-called UA Expert from the company Unified Automation, which offers a lot of tools around Opc Ua, and they offer a free of charge client, test demo client. And I will be using this one right now in order to see whether I can communicate with my Raspberry Pi via Opc Ua. The first thing I have to do is to add a server, and I could now add a new one, but you see that I have already prepared the server on my Raspberry Pi. There's the IP address and the channel for it, and I can browse it, see that server here, connect it, not connect it, but install it at first step. So I just edit it up here. There's a message window, a log window, and with the next button here I can connect to the server, and if everything works correctly, then the server is connected, the browse succeeded, and you see down here all the objects which are now transferred by the Opc Ua server on the Raspberry Pi to this client. So we can now browse to the variables. You see that there's Raspberry Pi detected, there's some resources, the application, and we see here global variables. Oh yeah, here's my counter. Just put it into that data access view. Perhaps we take some others, some other programs, the PLC PRG, and perhaps we put some of the data immediately in here. We can open the instance of such a function block. There's another function block which we can open and monitor in here. And we see all the variables immediately in online mode. So in order to show you that these have the same data, I bring the CODESYS development system in online mode to the background. So we see here, for example, that counter is somewhere around 600,000, and it's of course the same in here. And I can now change the variable here, and in those views this value is updated and processed once again. Okay, so we have the first Opc Ua communication realized. Now there's already one difference to standard OPC. We have the server not running on the PC but on my Raspberry Pi. Now I want to go even one step further. I want to get a little bit rid of my PC or of a Windows system in order to show you that it's really now independent from any Windows. And for this purpose I have prepared my mobile phone, which I can mirror here on my PC. So you see that nice flowers on my mobile phone, and there is a demo client as well for Android. I'm using an Android phone, and this is something I want to start right now. It's Opc Ua Client from CODESYS, and you see that again here I already prepared the same IP address for that Opc Ua configuration. I connect with my server on the Raspberry Pi. It's connected. No securities installed so far. As I mentioned, it's not yet available. Now I can go to the menu and browse which variables are running on that Opc Ua server. Go to Objects, Device Set, similar as on the UA Expert, but in this case it's really a Linux or Android system. Go to the application, global variable, and you see here's my counter. Could get the recent value, it's 25,000 something, yeah, fits together to the variables here. But I could as well monitor it, put it to a monitoring window and see this variable running here. So we could even write it with a new value. Okay, it's written down here, it's written here, it's written here. So as announced, we have now a really completely Windows independent communication from my Raspberry Pi running the Opc Ua server to my Android phone running an Opc Ua client. So let's switch back to the presentation. Just a short summary. For the preparation of the data export, I need to add the simple configuration. I need to publish the relevant variables. Don't forget to build the project before you can do that, but anyway, CODESYS will show you that this is necessary. Then we need to activate the Opc Ua export, download everything to the controller, and then the CODESYS Opc Ua Server is ready. And on the other side, the client needs to establish the connection to the server, browse all available data providers, so there might be different data providers and different available variables, and then we can show them and monitor them. Of course, in this case, this is not a real visualization, it's just a test or a demo tool in order to see whether the communication is working, but it would work in the same way with any Opc Ua client. Let's come to the end, a short outlook. As mentioned, there are still some things that we have on our roadmap, for example, that X509 security certification. Furthermore, we are working on an Opc Ua client, which will be probably available in 2017. This will include an IC library interface, runtime system interface. So this means similar to the Opc Ua server, this client will be part of a runtime system and maybe included as well on your target controller in case you're a device manufacturer. Furthermore, we will include that Opc Ua client in CODESYS HMI. CODESYS HMI, for those who do not know that tool, is a standalone visualization which may communicate to CODESYS version 3 devices. With Opc Ua client functionality, it will be even more flexible because then you can as well communicate with any other Opc Ua server, for a server which is running perhaps on a Siemens controller or any other controller. So this makes the visualization much more flexible. One more thing that we have on our roadmap is a standalone Opc Ua server, which needs, of course, a connection configuration, which will be available for version 2 and version 3 controllers. So this will open as well the possibility to connect version 2 controllers to Opc Ua. At the moment, you have the only possibility to use a soft PLC, for example, running on a PC, which collects the data, which has the Opc Ua server implemented. This is a quite good workaround, but perhaps much more expensive and much more performance-consuming solution. So as a conclusion, we can say that the CODESYS Opc Ua server is very flexible because it can be installed together with the CODESYS control runtime system on almost any controller. Appropriate resources are, of course, recommended. So for those of you who are device manufacturers, you can purchase this option as a buyout to your runtime toolkit. Please contact our sales team for data sheets or a quotation. Concerning the application, it's very good to know that there is a uniform configuration and application of both Opc and Opc Ua in CODESYS. So in fact, both transfer protocols can be used in the same time. So with that simple configuration, you can have an Opc client and an Opc Ua client running or being connected to your controller at the same time. And for applications or tests, you can immediately use soft PLC systems, as already mentioned, the CODESYS control WinSL, the soft PLC installed with the development system, or for example the Raspberry Pi in case you want to have a dedicated device separated from your PC. And there are some other devices as well already available on the CODESYS store. For example, there is a soft PLC for the Vago PFC 200. For those of you who are end users, they could immediately take that device, which is then programmed with the standard CODESYS development system. Okay, now I'm at the end of the presentation of that webinar. Thank you for your attention. The chat is open. You can immediately pose your questions in the chat right now, or you send me an email to r.wagner@codesys.com. We will be happy to answer your questions either right now or afterwards via email. Thank you for your attention, for following at that webinar. You can register on our YouTube channel to get the webinar upload, so as soon as it will be available. This might take 2-3 weeks until we have post-processed that video and deleted all my A's and O's. And I'm looking forward to meeting you perhaps somewhere on a fair or somewhere else. Thank you and bye-bye.